All right, 6.5, integration by substitution part 1. I separate this into two parts because part 1 will be the indefinite integrals and part 2 will be the definite integrals, okay? So this is your reverse chain rule pretty much, okay? So remember chain rule when we did derivatives? How we multiplied what was inside of parentheses by the derivative function? Now it's backwards, okay? So it's like if we have a function where we're multiplying by the derivative inside the parentheses, it just goes away because it's the antiderivative, right? So another method we're going to be working on here is if we were to make this u, it's sometimes easier to work with, and it's a much more simpler process, okay? So if we have f of u, then the antiderivative will be capital F of u plus c. Okay, so that's another. We'll be working with both of these methods. Some cases will be easier than the other. You must use this way in some cases. Okay, so we'll go through a bunch of these to give us a clearer picture. All right, first example. So we got the integral from, well, not from anything because it's not a definite integral. Integral of x squared minus 9 to the third power times dx times 2x dx rather. So what do we notice right away? So is this right here the derivative of this? Yes, it is, okay? So that means that can go away whenever we work this out. And we're going to move to the power of 4 times 1 over 4, just like we would our normal power rule for integrals. And then we got plus c. So that is your final answer. And then 2x went away. I'll go over again. Since inside the parentheses here of an exponent, the derivative of it is on the outside here, it goes away. We see examples where they don't match up, you betcha. We'll be doing some of that in a little bit, okay? Okay, another example. Same story here. Inside the parentheses here, is this the derivative inside the same as this? Yes, it is. So we lucked out again, okay? So what I can do, since that's as if it's to the 1/2 power, right? This is 1/2, right? Therefore, we can just add 1 to the exponent, which is 3 over 2. And multiplied by, or excuse me, divide by 3 over 2, which you're going to be, it's like multiplying by 1 over 3. Integral goes away, my bad. Plus c. The negative 2x goes away. Remember, you divide it by 3 over 2, flip the fraction, you get 2 over 3. So this one's a little different here. All right, so we have here, a derivative inside here is 3x squared. That doesn't match up here. So what can we do about it? Okay, because it should, if this was a 3x squared, we'd be in the running, right? We'd be able to cancel it out, apply a rule, we're all good. So what we're going to do differently, I'm going to change this problem. I am going to make this 3x squared, haha. But I'll be completely changing a problem, and that's bad, okay? We can't completely change a problem just because we want to, okay? It doesn't make it easier, right? But what I can do is I can put a 3 right there and then write a 1 over 3 on the outside. Why? 1 over 3 times 3 is 1. So I'm not changing a problem then. So whenever I go to integrate this, okay, first off, I can make my life even easier and move the 1/3 way up front, okay? We just multiply it at the end, okay? Which is neat. Now it's just like the other problems. We love that. So I'm going to add 1 to the exponent. And divide by the new exponent over 5 times 1/3 plus c. Can't forget our plus c. 1/3 times this will get us 1 over 15. I'm not going to even bother writing the 1 there. That was a little extra. 1 over 15, so it'll just be x to the third plus 5 to the power of 5 over 15. Plus c. There's our answer. All right, so this is where we're going to, what I put in the notes, change variable. okay? And here's the formula for it, and really this is what you might know as U substitution, okay? So we're going to be practicing with this method in order to solve. So we're going to give you an example. All right, so that last problem we did, we could have done with U sub, okay? So what I'm going to do is whatever is inside the parentheses that, like this, is a good idea to make our U. So we're going to set U equal to t to the fourth plus 5, and we find a derivative of U, which is 4t dt. Okay? I want this, I'm sorry, I should have been 4t to the third. Almost a big mistake. What I want, I'm going to get, whatever this is, I want to get that by itself here. Okay? So I'm going to divide by 4. We're going to get du over 4 equals t to the third dt. So now what? I have a t to the third right here. I have a dt right here. What I'm going to do is instead of writing a t to the third and dt in the problem, I'm going to substitute in du over 4. Okay? Also, I'm going to, since u is equal to t to the fourth plus 5, as I established, I will be substituting in u into t to the fourth plus 5. Now I'm going to make this look a little prettier, okay? So I'm going to make it 1 over 4, u to the 1/2 du. So now we are integrating with respect to u. Much easier problem than one we did similar to the beginning of the chapter, right? So if I add 1 to the exponent and divide by whatever the new exponent is, we flip it, make a multiplication, so it's going to get us 2 over 12, which reduces down to 1 over 6, u to the 3 over 2 plus c. At the end, you cannot forget to put in whatever our u is at the very end. So your answer is 1 over 6 t to the fourth plus 5 to the power of 3 over 2 plus c. There's your answer. Let's do another u substitution so you get used to it, because once you get used to it, it's one of the easier methods. So I'm going to set u equal to 1 plus x to the fourth. The derivative of that is going to be 4x to the third dx. Okay? So once again, what's outside of our u in this problem? Okay, what is an x to the third, right? So we need to get x to the third by itself. So divide by 4. Again, it's not always going to be 4, but it is in this case. Our two examples, just ironic. So I'm going to replace x to the third dx with du over 4. So your new problem is going to be 1 over u. I'm going to make it 1/2 power, okay? Make our lives a little easier. Also, 4 is in the denominator because you're dividing by it, du. Another way to write it to help us with our integration is u to the negative 1/2 times 1 over 4 du. Okay? Add 1 to the exponent. Negative 1/2 plus 1 is 1/2. Divide by the new exponent, which is 1/2 plus c. Flip it and make a multiplication, which will be 2 over 1 times 1/4, which is going to get us 1/2. 1/2 u to the 1/2 plus c. Substitute in our u, so it'll be 1/2 1 plus x to the fourth to the 1/2 plus c. Now, next on my guided notes, I have general power rule for integration, which is what we've been doing the whole video. Okay? General power rule. for integration. Okay? So if I have this integral, dx, just like you would add one to the x one divided by the new one, right? So nothing new. I'm kind of wondering why the book included it right now after we did problems like this, but it is what it is. Okay, and that's what it would be. Okay, identical to what we just did. Okay, if it was used substitution, same story. U to the n du, u to the n plus 1 over n plus 1 plus c. Okay, I appreciate you watching, and we'll see you in class.